Okay, quick look here at this question on page 5. It's a square base pyramid that gets tilted up so that the base is at 45 degrees to the ground, to the horizontal plane. So just project up. AB is the edge that stays on the ground. So I'm going to call this CD, but CD gets lifted up in the air afterwards. So I'll just project it up. So it goes 45 degrees to the ground, okay, to the horizontal plane. So I set up an angle of 45 degrees there, and I'm just going to swing that up. So this is an edge view of the base. So that's BA looking from the front. This is CD, and the center of the base is what I want to find next. The center of the base, and I'll explain why now. Here's the center of the base, and at 90 degrees to that is the top. So they told us in the question here that the pyramid was 55 high, so it would have been 55 above the ground. So I didn't bother drawing it standing on the ground because it would be only confusing. There's 55 high. So there's O is the top of the pyramid. So there's our elevation. So when the base was tilted up, I'll just draw the plan of it now. So CD would be moved up to here. So this is the real position of D. This is the real position of C. A and B stayed on the ground, but obviously I'm not going to be able to see them now because they're going to be underneath. So I'll draw the apex. So the apex, when that pyramid tilts, the apex is going to come over to here. So I'm going to draw now my four edges. OD, OA, OC, OB, and that's along the ground there. So we can see that. And finally there, just to kind of help you picture it, if AB is on the ground and CDO is that top triangle. So CDO is that top triangle. This is it looking down from above. So that's the triangular surface that's on at the top, and that would be it here. I think it helps to just put some bit of color on it anyway. Okay, so that is just tilting a pyramid on an edge. Now the next one here, so the base, it hinges on that AB line, so it's kind of the same as the one we just looked at. It's tilting along the AB line, so I'll just set up the elevation. So AB, I'll call it BA because you see B first and then A. So just grab a set square. So the base of the pyramid is tilted at 30. to the horizontal plane. So the base makes an angle of 30 and the height of it is going to be 60 millimeters high. Okay, so what I need to do now is just find where the other corners would be on the ground if it was sitting down straight. So that would be C and D and E and F. So when it was on the ground, that would be CF, and that would be DE on the ground. But they're not left on the ground because they're swung up in the air. Now a faster way of doing that would have been just take the distances from plan here and mark them, because they were true lengths when it was sitting on the ground. So I could have, if you know what you're doing, you could have just taken them and marked them straight, but I don't want to confuse people by doing the fastest way. So here is our prism. There is the elevation. So now when I project these down, so that's going to be dotted because that's on the underside here. I'll put some colors on this afterwards. Now the top edge there, the top corner points there, then for C is going to be there, F is going to be here, because when they tilt, the points move at 90 degrees to the hinge line. The AB is called the hinge line. So we now have the final positions of C and F. And finally, I want the top of E and D, which appears to be here and there, so just barely forward. Okay, so there is our finished shape. Okay, now I'm going to put just maybe 2 colors on this to help. So if we decided that top surface here is yellow, so that top surface tilted yellow is here. And the other color I'll use here, I'll just use purple or something. So that AB surface here is in here. And we can't actually see it in plan. Okay, where would be the edge of it there, but you can't actually see because the rest of it's going back down to the ground. So, yep, That's about as good as that gets. So the plan, draw the plan elevation. Oh yeah, they asked for an in view here now. Okay. So we'll just draw on our 45-degree line. Project them over. Okay, so my two top points, A and B, are going to be in the center. And so that is that top surface. Just draw that first. So that there is ABDE. And then C and F. Out, so I'll just draw that end hexagon here. Then just bring this across. Join a few lines here and you'll just see then what's going on here in a second. Okay, so we're just looking in from the side then over here. So here's our base. Might just put a color on that as well. So if I put the base in here in green. So that green base is here in the edge view. You can't see it looking down from below. So there's our end view here. Now I'm just going to go back up there to that last question because I noticed that they look for an end view in this question as well. So we just throw in an end view here. It won't take 5 minutes. So bring up AD, bring up the apex, bring up C and B. So I'm going to bring across the apex here, which is O, and label that. Now I'm going to follow my points here. So here's the height across. So D is up in the air, whereas A is on the ground, B is on the ground, C is up in the air, and when I'm looking in from here, I'm going to see CD. Now all the edges join to the apex. just put my colours on that there finally. So again there, that yellow CDO surface is here. So we're seeing the base, and yep, that's it. Now question 2 here then. The plan of a square base prism, altitude 40. The prism is rotated about at 30 degrees to the vertical plane. Now that could go, I'm going to presume that what they mean, it's not worded the greatest, but I'm going to presume that they're saying that it gets rotated around like this. So that corner moves down to there. I think this is what they mean. And then, so the other two edges then are going to be going at a 60-degree angle. So the size of our, or the orientation of our plan is going to be like that. So that's the plan. So I'm going to call that B and C and D. So when I bring this now up to elevation, here's D. Here's A. Now because A is at the back, if you're looking in from there, you're not going to see A. Here's B. Here's C. Now we were told that the height of this is 40. So that comes over, and then the rest of it is cut by that plane here. Now we're presuming that this is just a simply inclined plane. So that is D being cut up there. That's A being cut. This is C being cut here. And F is not cut at all. So there's a line along here like this. Okay, and I'll just stick a color on this to help people see. So if I decide that that surface up here that's not cut at all is green. And might just stick the cut surface in yellow. So the cut surface is running down from there to here. This is it in plan. Okay, so throw a quick in view on this. 45 degrees. So just bring them over and up. Bring the heights across. So you're better off to mark them as you go in case you get confused. So that's D. Here's A. There's C. And F isn't cut. Or not, no, not F. B isn't cut. So B is here. Sorry. That's B is the full height. Okay. So I'm going to just join. So this would be edge B. And that would be edge C. There and there and D, and over here at the back would be A. So A joins to D, D joins to C, D joins to C, C goes into this point here. Now I'm going to call this 1 and 2. Now they're at the top height, so when I bring these over and up, they are at the top height. So that's 2 and 1. Okay, so A goes to 1. C goes to 2. Then it's horizontal along here. Just heavy in the vertical edges here. Throw a few colors on this. Green surface is up on top here now, that going from 1 to 2. And there we go. So the key concept here was, will the cube be rotated in the plane or the elevation? Well, if it was rotated to the vertical plane, it had to be in the plane. Okay, if it was rotated to the vertical plane, because that's where you're seeing the edge view of the vertical plane. So that's that one. Now this last question here, it's a hexagonal base pyramid and it's rotated until the apex O is on the ground. So what I'm going to do there, it says that the altitude is 50. So I'm going to just mark that is the apex. And I'm going to just bring up now. I'll number this 1, 2, 3, 4, 5, 6. Okay, but 1, 2. There is, sorry, that would be 2. And we can't see 1. but it's hinging here until that's on the ground. So I want to draw the edge view of that edge there. That's 2, 1 and O for the apex. Now I'm not going to draw the rest of the pyramid because it's only going to be a distraction really. So that's that edge when it's sitting on normal, but when it's rotated down to the ground, just throw an arrow on that to say that that's going over and down. So here's my edge on the ground, and basically then you need to just understand a small bit of geometry here then, in that if this is definitely O, so that's the length of 2, 1 from the top down to those 2 points. That will also be the distance for the other side there, which is 4, 5, and we know that the width of the base, I suppose there's 2 ways now that I could do this. It might be easier to do it the slower way, but it's easier to understand. So if I bring this up here and I draw the base in here in green, so there's the base when it's on the ground. So when that base swings up, it's going to come up on that arc, and the distance from, as I said, the top down to 2 and 1 is going to be the same distance as the top down to 4 and 5. So that's over here. So here is my base. I'm going to put that in green now. So that's my base when it's tilted. Going back down to the apex, the other side. And finally now I need to just mark in three and 6 coming up there. So that's 3 and 6. This is 4 and 5. 1 and 2 is still on the ground. So just draw that back into there. So this question said the solid is to be rotated until X rests on the horizontal plane, which it is now, and then draw the plan and elevation of the pyramid when it's rotated. So I have to just draw the plan here now. So again, I start with the apex here. That now, the key thing here is this is not a line. This is the top view of an arc as it swings up and back down and onto the ground. So there is the apex on the ground, and then 4 and 5 would be coming over to here. So 4, the final position for 4 would be there. Final position for 5 would be here. Then 6. Just bring 6 and 3 down next. So that's the final position for 6, because you can see 6 is actually up against the vertical plane, which is slightly unusual, but so 4 and 5, because 4 and 5 are the highest up in the air. We're going to see them when we're looking down from above. Definitely going to see them. So you're going to see it going down to 6, back down to the ground to 1. Same at the other side here. So there's my line along the ground, which is the 1, 2 line. And finally then, just put in these edges here, going to the apex. And I'm going to just throw maybe one color on this. So again, if the very top edge of this is the 4, 5 one, that's it here. That's it down here. For anybody that struggles with visualizing these, just picturing it in your head, a little bit of color and a little bit of numbering makes all the difference. Oh God, I shouldn't have used green. I shouldn't have used green because I had used green for the base. I might just cheat here now a little bit, and I'll just change the base setting to red. So the base is red. Red, that was the red base when it was on the ground, and green for that surface, and I can't see the red over here. So that is a good sheet there now, very, very good sheet on visualizing rotations and cuts and cut surfaces and all that. So yep, plenty to do.